Hello, everybody. This is Dr. representing sets 2. Well, it's with the assumption that you've seen sets 1. Well, if you haven't done so, please quickly do so. The link to it is given to you here, and it's for the lecture to flow adequately. All right. So we want to start from union this time around. Union and intersection of sets. Let A and B be any pair of sets. The union of them, denoted by A union B, is simply that. That is, collection of x's that are strictly in A or strictly in B or in the overlap of A and B. That means they are in both A and B. Example, let E be this and P be that. Then E union P will be this. The collection of elements that is in both of them, that is the union. All right. Intersection. Let it will be a collection of elements that are either in I and that are either in that are either of them or both of them. Yes. Now intersection. Let A and B be any pair of sets. The intersection is denoted by cap B and is a collection of elements that are both in A and B. Let A and B be any set. If you look at the intersection of E and P, it will be singleton 2. That will be, but note that union is always contained in intersection. Cardinality and further examples. Let A and B be any pair of finite sets. Their cardinalities we denote by n number of elements in A, number of elements in B. Cardinality of the union will be number of elements in A plus number of elements in B minus number of elements in their intersection. Where when they are mutually exclusive, then the cardinality becomes null. And so this equation will reduce to this. Well, example, look at this. Number of elements in A and number of elements in the complement will simply be number of elements in the union. A intersection B will simply be singleton 2 and the cardinality will be 1. Okay. Subset. There are two types of subset, proper and improper. Either way, so if a set B contains none or some or all of the elements inside the set A, then B is a subset of A. No. Note it, null set is an improper subset of all sets, including itself. Well, a set A is improper for itself. The null set is improper for it. Any other set that has at least one element less than the content of A is proper for A. Exercises. Well, given that n is that, p is that, it says x is a natural number and x is the solution to this cubic equation. The only solution to this cubic equation is x equals to -3, and -3 happens to be an integer. It isn't a natural number as such. This set is null, it's empty. Well, x is odd and x is natural. This is just the set of odd numbers because this is the universal set to this. Okay, just think about these questions. They are very doable ones. Union, for instance, look at A union B. The number of elements in the union will be 5 because if you unite this and this, you will have 5 elements in there. Okay. Then another thing that is important is the power set. The number of objects inside the power set is usually 2 raised to power n, where n is the number of elements inside A. This is an illustration. We are given a set, a ground set that has 2 elements, yet its power set has 4 elements, although those are sets. And that is, and 2 raised to power 3 is indeed 4. Okay. Venn diagrams. These are representation for the union. The diagrammatic representation for the union, diagrammatic representation for the intercept, the shaded zone. Okay, the intercept. As long as they are not disjoint, there are still some more. Fine. This is A, not B. Anything in A, but not in B, or even elsewhere. Then this is B. This is A complement. Anything that is outside A. This is B complement. Anything that is outside B. This is A union B complement. Anything that is outside the union of A and B. When there are 3 sets, this is the scenario. Okay, but there are 4 sets. It will be becoming clumsy because the scenario will be like this, and there will be as much as 9 overlapping regions. And then, anyway, we don't really need to list. I mean, we don't really need a diagrammatical representation to solve our story problem. Because when the number of sets becomes 4 and above, it's very, very clumsy. So we'll assume that we will use something else, because there is actually a formula that will be usable whenever we have story problems. Now, this is an exercise. Now, if you read through this, you'll find out that from what I've talked about, there are two methods that can be used to solve it. Either through arithmetic piecing of the values on the Venn diagram, or the use of the formula. Well, from this, we can draw a Venn diagram that looks like this, the Venn diagram of the question. Right now, and if we fix arithmetically the values of these alphabets, we will see that this is the result. But it didn't just come from the blues. What did we do? How it is done? There are two methods, like I said. We can fix it algebraically. If you look at the verbal question that was posed, you will see that we were told that 41 could do the 3. Only 7 can teach English and science. Only 1 can teach science. These are just summary mathematical representation of the statements in the story problem. And armed with this, when we have all the equations involved, we will just solve those equations simultaneously. At the end of the unknown that we are asked to find, in this case, those who can teach mathematics alone, we found it to be 6. Just solve the equations simultaneously, you get 6. Okay, if we had wanted to use the formula, then we will have to check whether there are some teachers that are not qualified to teach any of the trio. They are not qualified to teach any of the 3 subjects. Then we will have to find that first. In this case, when we summed up and removed that from the universal set, we found out that there exists a teacher. Okay. This means there is a teacher that is not qualified to teach any of the 3 subjects. However, if you know that if by the time we say cardinality of E, we mean everything inside E. Cardinality of M, everything inside M. Then you will know. From there, you can fix the formula. This is the formula for 3 sets: English, math, science. Use the formula and you arrive at these unknowns, those that can teach mathematics and science and that can teach the 3, you find it to be 42, find it out to be 42. And as such, those that can teach math and science, just 1. From there, if you go back to the set for mathematics, you find that those that can teach math alone are 6. So either way, the solution is 6. Continuity. This is the farthest we will go for now. Otherwise, the video will be too long, too big, and unacceptable. Look out for set 3 in a few days' time. Bye for now. Thanks for listening and stay blessed. Thank you.